From a young boy nicknamed Math Master to a professor challenging global paradigms, this is the journey of Professor Mohammed Usman. Gifted by God, he raced through school, best in class, top in state from Abdulaziz Atta Secondary School, where he earned another title, Uzi, for speed and precision. Top again at Ahmadu Bello University Zaria. One moment, one compliment, one lunch. And academia found its star. Today, this professor of chemical engineering challenges the world's view on carbon, armed with data, divine insight, and decades of research. From Mr. to Doctor, from Doctor to Professor, a teacher, a thinker, a legacy in motion, fueled with a BEng in chemical engineering from Ahmadu Bello University, an MSc and PhD in chemical engineering from the University of Lagos. What's the latest today? Is carbon truly as guilty as charged? To find out more, join the upcoming 19th inaugural lecture at JF Ade Ajayi Hall, University of Lagos, live on the 6th of August 2025 at 4 p.m. From a young boy nicknamed Math Master to a professor challenging global paradigms, this is the journey of Professor Mohammed Usman. Gifted by God, he raced through school, best in class, top in state from Abdulaziz Atta Secondary School, where he earned another title, Uzi, for speed and precision. Top again at Ahmadu Bello University Zaria. One moment, one compliment, one lunch. And academia found its star. University of Lagos. What's the latest today? Is carbon truly as guilty as charged? To find out more, join the upcoming 19th inaugural lecture at JF Ade Ajayi Hall, University of Lagos, live on the 6th of August 2025 at 4 p.m. From a young boy nicknamed Math Master to a professor challenging global paradigms, this is the journey of Professor Mohammed Usman. Gifted by God, he raced through school, best in class, top in state from Abdulaziz Atta Secondary School, where he earned another title, Uzi, for speed and precision. Top again at Ahmadu Bello University Zaria. One moment, one compliment, one lunch. And academia found its star. Today, this professor of chemical engineering challenges the world's view on carbon, armed with data, divine insight, and decades of research. From Mr. to Doctor, from Doctor to Professor, a teacher, a thinker, a legacy in motion, fueled with a BEng in chemical engineering from Ahmadu Bello University, an MSc and PhD in chemical engineering from the University of Lagos. What's the latest today? Is carbon truly as guilty as charged? To find out more, join the upcoming 19th inaugural lecture at JF Ade Ajayi Hall, University of Lagos, live on the 6th of August 2025 at 4 p.m. From a young boy nicknamed Math Master to a professor challenging global paradigms, this is the journey of Professor Mohammed Usman. Gifted by God, he raced through school, best in class, top in state from Abdulaziz Atta Secondary School, where he earned another title, Uzi, for speed and precision. Top again at Ahmadu Bello University Zaria. One moment, one compliment, one lunch. And academia found its star. Today, this professor of chemical engineering challenges the world's view on carbon, armed with data, divine insight, and decades of research. From Mr. to Doctor, from Doctor to Professor, a teacher, a thinker, a legacy in motion, fueled with a BEng in chemical engineering from Ahmadu Bello University, an MSc and PhD in chemical engineering from the University of Lagos. What's the latest today? Is carbon truly as guilty as charged? To find out more, join the upcoming 19th inaugural lecture at JF Ade Ajayi Hall, University of Lagos, live on the 6th of August 2025 at 4 p.m. From a young boy nicknamed Math Master to a professor challenging global paradigms, this is the journey of Professor Mohammed Usman. Gifted by God, he raced through school, best in class, top in state from Abdulaziz Atta Secondary School, where he earned another title, Uzi, for speed and precision. Top again at Ahmadu Bello University Zaria. One moment, one compliment, one lunch. And academia found its star. Today, this professor of chemical engineering challenges the world's view on carbon, armed with data, divine insight, and decades of research. From Mr. to Doctor, from Doctor to Professor, a teacher, a thinker, a legacy in motion, AWWALU with a BEng in Chemical Engineering from Ahmadu Bello University, and MSc and PhD in Chemical Engineering from the University of Lagos.
Distinguished ladies and gentlemen, good afternoon. Please, let's be upstanding for the university procession. Let's remain standing for the university anthem.
Shall we sit, please? The Deputy Vice Chancellor, Development Services, Professor Folusho Leshi, the Deputy Vice Chancellor, Management Services, Professor Muyiwa Falaye, the Registrar, Mrs. Abosede Wycliffe, the Bossa, Mrs. Olufunmilola Adekunle, the University Librarian, Professor Olatokunbo Okiki, the Provost College of Medicine, Professor Ademola Oremosu, the Dean Faculty of Engineering, Professor Samson Adeosun, distinguished ladies and gentlemen of the press. It is with great pleasure that I warmly welcome you to the 19th inaugural lecture and the 441st inaugural lecture in the series of the University of Lagos. The title of our lecture today is Carbon Truly as Guilty as Charged? The Perspective of a Process Systems Engineer on Sustainability. Our inaugural lecturer, Professor MOHAMMED AWWALU USMAN, is an associate professor of chemical engineering. He was born on Sunday, February 25, 1968. He holds a BSc Engineering, Chemical Engineering from Ahmadu Bello University, Zaria, as well as an MSc and PhD in Chemical Engineering from the University of Lagos. In 1994, Professor Usman began his career by joining the services of University of Lagos as a graduate assistant in the Department of Chemical Engineering. He rose through the ranks and he became a professor in the year 2020. He is known in his chosen profession, where his area of specialization is process system engineering, sustainable process technology. He has also worked extensively in the area of biofuels and development as a catalyst for sustainable energy, adsorption, catalysis, and chemical reaction engineering, and also in polymer and composite materials. His major research area is in process systems engineering with focus on resources conservation. His major interests are in the area of reaction engineering and polymer composites. Professor Usman is the immediate past Managing Director of Unilag Consult Limited and currently the Director of one of the centers in the university, and that is the Unilag Center of Excellence for Smart Petroleum and Energy Systems Technology. He is a seasoned academic with over 60 national and international publications in journals, conference proceedings, and books. Professor Usman is happily married and blessed with children. Distinguished ladies and gentlemen, join me in welcoming to the podium our 19th inaugural lecturer for the 2024-25 session, Professor Mohammed Usman, as he presents his inaugural lecture. Thank you.
The Vice Chancellor, the Deputy Vice Chancellor, Academic and Research, the Deputy Vice Chancellor, Development Services, the Deputy Vice Chancellor, Management Services, the Registrar, the Bursar, the University Librarian, the Provost College of Medicine, Dean of Faculty of Engineering, Deans of other faculties, members of the University Senate, the Head of the Department of Chemical Engineering, other heads of department, professional and academic colleagues, non-teaching members of staff, administrative and technical, your lordship, temporal, dear students and alumni, members of the mass media, press, broadcast, and virtual, distinguished ladies, distinguished guests, ladies and gentlemen. It is with pleasure that I stand before you today to deliver my inaugural lecture. My trajectory in the academia has been a one-way traffic, thanks to fate and destiny. Very early in life, I realized the divine gift in me, and that is the ease of assimilating concept and disseminating same with greater ease. My classmates all through recognized this and indeed already predicted that I was headed for a career in the academia. I, however, even though I know I am a natural teacher, I had my eyes on the oil and gas sector because of the poor remuneration of lecturers. So when I reluctantly came for my master's in 91-92 academic session, late Professor Oluoboja discovered me and rerouted me back to my natural habitat by encouraging me to do a PhD under his supervision. And this marked the beginning of my journey in academia. Professor Oluoboja delivered the third inaugural lecture from the Department of Chemical Engineering in 1998, and it was titled, "The Making of the World Plant." That world plant is now challenged to align with sustainability paradigm. This is largely because of climate change. Yes, I agree that there is climate change. But what I find concerning about the ongoing mitigation action is the demonization of carbon. So, today, as I deliver the 8th inaugural lecture from the Department of Chemical Engineering, I intend to interrogate this narrative, provide a different perspective, and as the hallmark of a professor, I will prophesy on what we stand to people on this part. So today, I take on the role of a judge in the case between Carbon and his accusers. I shall be guided by the principle of fair hearing. And I have a very rich family history in this regard. My great-grandfather, Adai Abdullahi Umajene, was the very first judge in Ibira land. Upon his death, he was succeeded by his son, my grandfather, Adai USMAN Aningere. Seated in the audience today is my cousin, Justice Isiaka Usman, the current president of the Customary Court of Appeal. So, fair hearing runs in my family. Madam Vice Chancellor, I welcome you to my inaugural lecture titled, "Is Carbon Truly as Guilty as Charged? The Perspective of a Process Systems Engineer on Sustainability." Now, United Nations, sometime in 2015, gathered a number of countries together, and they put up an all-encompassing framework for socio-economic development. And we can see that here, they are tagged the SDGs. All of these 17 SDGs are geared towards achieving 5 things: profit, people, planet, peace, and partnership. But actualization of these entails consumption of huge resources. And SDG 12 here says we must, in consuming resources, we must be responsible. So it provides for responsible consumption and production. Now the question is, how responsible have we been in the consumption of resources? To put this lecture, and indeed the trial, in proper perspective, let us look at the consumption model of carbon resource. This figure shows us what we presently do. Fossil fuel comes in here, air goes in to burn it. That reaction is highly exothermic. It releases energy. That is the energy we need to power our systems, vehicle, at home, and all that. But it is only a fraction of that energy that is put to use productively here. The rest live with the flue gas as it emerges, and that is what we throw into the atmosphere. It is this CO2 that is being accused of being responsible for climate change. So we can start the trial now. The prosecution team has the following claims against carbon: that carbon is a catalyst for global warming, that is a driver of fossil fuel dependency, that is an agent of ocean acidification, and that it drives global inequity. So, the final submission of the prosecution team is that carbon that is emitted on account of fossil fuel consumption and indeed other industrial operation is responsible for climate change, and that there is a need for us to keep the rise in temperature, global rise in temperature, below 2 degrees Celsius in order to avoid disaster. Hence, there is drive to move away from fossil fuel consumption by an agenda called decarbonization. So industries, private and public organizations are driven in pursuit of this decarbonization agenda. To this end, countries that are party to Paris Agreement on Climate Action meet annually under the auspices of United Nations Climate Conference of the parties, COPs, to review their commitment and set new targets. Now let us hear from the defense team. The defense team have the following in defense of carbon: that carbon is the basis of life, and that carbon has enabled development up until now, and that it is only an extravagant consumption of carbon resource that results in excessive depletion of this resource, and therefore excessive emission of CO2 into the atmosphere. So, and that carbon can be repurposed. So the final submission of this defense team is that CO2 emission is directly proportional to the resource that you consume, and that excessive consumption undermines sustainability, energy transition, and decarbonization agenda without considering responsible consumption is only an exercise in self-indulgence. Solar and wind energy that is being propagated as renewable and sustainable are not exactly so, because critical elements that are needed for the production and deployment of this are not renewable. Lithium, cobalt, copper, nickel, silicon, and all that. So, the choosing path of energy transition and decarbonization is tantamount to priming ourselves for what Joseph Heller, in his classic book, described as Catch-22, a vicious cycle. The real panacea submitted by this defense team is that the real panacea to sustainability is responsible resource utilization, not demonizing carbon. Madam Vice Chancellor, we have listened to the claims for and against carbon. There are two issues for determination arising from this. One, would the impact of CO2 be so profound if consumption of carbon resources has been the very minimum required, devoid of extravagance? Two, whose fault is it that utilization pathway was not created for CO2, both the material and the energy emanating from combustion, as practiced by nature? I will provide answer to this question leaning on my research contribution over the years. But let us quickly look at what does sustainability mean. Sustainability simply means catering to this present generation without jeopardizing or compromising the potential of future generations to enjoy same. So, as process engineer, when we carry out sustainable design, there are three bottom lines that we watch out for: economic growth, environmental protection, and social progress. So we ensure that we conserve resources. If there is need for us to recycle, we recycle, and if there is need for us to use, we reuse. Now, I will take us through my research contribution in 5 thematic areas to draw evidence in order to be able to declare a verdict on this matter. The first contribution is from the Port Harcourt refinery. Now, a refinery is a complex industry, but the very first major operation is the crude distillation unit. And in the Port Harcourt refinery case, the crude oil is available at 25 degrees Celsius in the storage tank. Before it goes into the column, it is needed to be elevated to 353. So this stream needs to be given temperature lift. The fractions that are coming out of the column, naphtha, kerosene, diesel oil, and the rest of them, occur at temperatures far higher than required, so they need cooling. Now, how do we meet this energy requirement of this stream? There are three scenarios that I want us to look at. Scenario one is where there is no integration, no synergy. You simply deploy resources. So the ones that require heating, you bring external utility to do the heating. The ones that require cooling, external utility comes in to do the cooling. That is scenario one. Scenario two is where you recognize that you need to harmonize. You can use the surplus in the process to make for the deficiency in the process so that you reduce the demand on external source. This was the actual design of the Port Harcourt refinery. Scenario three is my intervention. I looked at that process design and I retrofitted it with the knowledge of the very minimum that this process should consume. And that is the scenario three. Madam Vice Chancellor, what is the implication of all this on resource consumption, CO2 emission, and sustainability? That is what this table provides us with. Now, this table shows that the fuel oil consumption for heating for scenario one is 241 megawatt. For cooling, 211 megawatt. For scenario two, which is the actual design of the Port Harcourt refinery, because of the process integration that was carried out in design, it consumes reduced amount, 93.5 megawatt for heating and 81 megawatt for cooling. And this is my intervention. With the knowledge of the very minimum, I redesigned that process and it is now consuming 71.4 megawatt and 69 megawatt of natural gas for cooling. So based on this, you will see that using my intervention as the case study, since it is the one that used the very minimum, that scenario one is consuming fuel oil, natural gas, and therefore emitting CO2 in excess of over 200%. Now, the actual design of the plant is consuming fuel oil by 30.95% in excess, 17.22% in excess of natural gas, and therefore emitting 23.76 in excess of CO2 into the atmosphere. Now, that is exactly what you see again in this bar chart. But this scenario one we see here is a clear example of excessive consumption of resources, depletion of resources, excessive emission, and all of this undermines sustainability. But some few years down the line, Unilag Consult was given the job to carry out energy audit of the Port Harcourt refinery. And I was privileged to lead the field study. And our finding is that the plant had retrogressed from its design, scenario two, towards scenario one, in terms of energy consumption and all that. So, people talk about, electrification as an option against the fossil fuel consumption. If you do that under the scenario one that we are talking about, there will still be the excessive consumption of lithium, silicon, and the rest of them. So, really, what are we solving? Nothing. We are shifting from one situation to another because we are here to address the actual problem. Now, scenario one that we see here typifies our attitude towards resource consumption. Every one of us here, when you want to consume water for any purpose, do you use the very minimum required? Do you use the minimum that is required in terms of electricity? Every time you leave your office or home with appliances on, what you are doing is excessive consumption of resources, and the implication is that you emit into the atmosphere in excess. And it is not just individuals that do this. Even government. When government formulate and implement policies in silos, that is exactly what they are doing. A typical example of this is the next case study. The federal government of Nigeria is talking about, has a policy on rice sufficiency, has policy on biofuel production. and is pursuing each of these in silos. So, our intervention here was to look at these silos intervention by the federal government against an integrated process. We can integrate all of this, the rice production and the biofuel production, because rice production is associated with three wastes: rice husk, rice bran, and rice straw. We can produce these three biofuel. We can produce biodiesel from rice bran, we can produce aviation fuel from rice straw, and we can produce rice husk, bioethanol from rice husk. So, this is it. This is the standalone production as envisaged by the federal government policy for production of biodiesel from jatropha. This is the production of bioethanol, okay, from cassava. This is what you find scattered all over the country, producing bioethanol from cassava. And the next one is the production of aviation fuel from microalgae. All these are what the federal government policy envisaged. Now, this is my intervention, that we can produce biodiesel from rice bran, we can produce aviation fuel from rice straw, and we can produce rice husk. Produce bioethanol from rice husk. So this is the integrated plant. What is the implication of this? To put this in the context of this lecture, what is the implication of this on resource consumption? The resource consumption in this case are the land needed to grow this plant, to get the feedstock, the water, the energy, and then how much of CO2 are we emitting into the atmosphere. This is the standalone as envisaged by the federal government. This is the integrated from my intervention. And we can see that land use is reduced by a whooping 76%, water use 37%, energy 64%, and CO2 emission by 64%. The other issue we have with resource consumption is our linear consumption model. We take this resource, produce whatever useful product we want to produce, and after its useful life, we throw it into the environment, and it becomes another challenge: waste disposal. A case study is the waste tire. You see this waste tire all over the place. Okay, that government across all nations, okay, battle with how to dispose. But in this, I see huge opportunity for resource recovery. Now, when you pyrolyze this, what you get is pyrolysis oil that is very much like the crude oil, and from which we can get pyrolysis gasoline. Pyrolysis gasoline is very rich in aromatics: benzene, toluene, xylene. These aromatics are currently produced by the refineries. And there is huge market in Nigeria for aromatics. In 2023 alone, NMPC reported that a whooping sum of $1.5 billion was spent importing these aromatics to satisfy the plastic, the coating, the textile, and other consumer goods manufacturing companies. And this was because the refineries in Nigeria were not working. Yet, this is what we can easily produce from waste tire. So, my intervention here is that a crucial step in this valorization pathway is that we must be able to remove aromatics from aliphatic media. And this is done in industry by what is called liquid extraction, and the choice of solvent is very key in that process. What is being used in the industry is sulfolane. Now, this sulfolane is an organic, a volatile organic molecule, and therefore considered not sustainable, it is not green, it is not friendly to the environment. So my intervention here was to look for a green solvent that can suitably replace sulfolane. And we tried the butyric solvent. And our finding is that 5 of our solvents perform not just about the same, not about the same as the sulfolane that is used in industry, but that they are superior to sulfolane in performance. So, And having done this on bench scale, the next stage for us to make it attractive to the industry is to do a pilot plant study. So we designed this pilot plant, okay? We designed this pilot plant, and then we constructed it, and this is it. This was proudly constructed by the group that I lead, and it's there in the Department of Chemical Engineering. Madam Vice Chancellor, what is the implication of this on resource consumption, CO2 emission, and sustainability? That is what we see here. This is the sulfur performance. The natural gas that is consumed, that's the resource, and the CO2 emission. These are my 5 solvents. These 5 solvents drastically reduce the resource consumption and drastically reduce the CO2 that is emitted into the environment by as high as 64%. My next intervention is in the area of cement production. Cement production is hugely in use in Nigeria, and this is also one of the things fingered for CO2 emission. So, what we did here was to partially replace cement with calcine clay. And we have clays scattered all over the country, so we tried a number of such clays around the southwest, and then calcium carbide waste, which is the waste that the vulcanizers just throw away. Now, and our finding is that we have an optimum blend from using 75% of cement, 19% of calcine ifeintedo clay, and 5% of calcium carbide waste. Again, what is the implication of this to resource consumption, to CO2 emission, and sustainability? Now, we reduce the most important resource consumption in the manufacture of cement, that is limestone, by 25%. There is reduction in CO2 emission by 18.4%. And in addition, the heat of hydration, which is what is responsible for the crack that you see in building, we were able to reduce it by 14.7%, and the cost of production by 19.4%. This is no mean achievement, Madam Vice Chancellor. And the last that I want to showcase here is on polystyrene production. Polystyrene production is by the method of bulk polymerization in the industry. This process is highly prone to what we know as thermal runaway because of the high exothermic nature of this reaction and the high viscosity of the slurry. When this happens, accident, there will be explosion, and in most of these industries, there is loss of life in high magnitude. So, our intervention here was to provide solvent media to help dissipate this energy. And we tried a number of solvents, and the best happened to be acetone. Okay, acetone outperformed all the other solvents that we tried. Now, again, to put this again in the context of this lecture, what is the implication for resource consumption? This is the bulk polymerization that is presently in use in the industry. So my intervention using solvent has again been able to reduce resource consumption by 39% and CO2 emission by 41%. Madam Vice Chancellor, the first question for determination has now been sufficiently answered, and that is that it is our extravagant consumption that is responsible for the huge amount of CO2 that we put into the atmosphere. Now, the second question, which is, whose responsibility is it to provide a pathway for utilization of the CO2 that we are throwing into the atmosphere? To respond to this question, I will draw inspiration from nature. And this is it. This is the natural carbon cycle. As we can see here, the human being takes oxygen to support this metabolic process and emit CO2. This CO2, as it comes out, is at ambient temperature, so it carries no excess energy, and it is not stored in the atmosphere. Plant takes it to support its own photosynthesis, and that is how the cycle goes. So on net basis, there is no CO2 left in the atmosphere. Now, based on this, drawing inspiration from nature, I therefore come up with this new metric for carbon utilization. I call it carbon utilization efficiency, where we track the elemental carbon. So I say carbon in minus carbon out is divided by carbon in. Now, if you use this to assess that natural cycle, the efficiency is 100%. But look at our own consumption model, where we bring this fossil fuel, we burn it, and just throw all of the things into the atmosphere. The efficiency is 0%. This is where the issue is. And what this means is that we should create a utilization pathway for the CO2 that we throw into the atmosphere. So this underscores our linear consumption attitude and the need for us to think circular to make use of all this. Thankfully, scientific findings are now coming out for CO2 utilization. So what is now left is for process systems engineer like myself to come up with sustainable process technology for transforming these scientific findings to the industry. And this is my current research interest. So, what has been happening is that we consume carbon resources extravagantly and in a linear manner. So, we have actually been abusing carbon. And now that the consequences have become our reality, we have shifted to demonizing carbon. So, I want to propose here, therefore, that rather than talk about decarbonization, we should strive to make carbon deliver more. Okay? We should get more value from carbon. So I advocate for recarbonization instead of decarbonization. Now, let's quickly do a critique of the UN and other funding agencies' intervention in global mitigation action. And that is what we see here displayed. There are 4 thematic areas that UN identified in its climate mitigation action: renewable energy, energy efficiency, carbon capture utilization, and carbon capture storage. Now, this is the funding from UN. This is from other global funding agencies. And we can see from here that the funding is disproportionately skewed in favor of transitioning to renewable energy and energy efficiency. Virtually nothing is spent in the area of carbon capture utilization or carbon capture and storage. And this is exactly where the UN and other funding agencies need to do a rethink. Conclusion. Climate change is driven by irresponsible and excessive resource consumption, not carbon. True sustainability lies in efficient resource use, not merely shifting to alternative. So, the real issue is how we use resources, not the type of resource. We should never abuse nor demonize any resource, carbon inclusive. So, my verdict is that carbon is not guilty, mismanagement is to blame. Therefore, Madam Vice Chancellor, I therefore hereby declare that carbon is not guilty and is hereby discharged and acquitted. Recommendation. The very first recommendation is that in our use of resources, we should endeavor to find out what is the very minimum that is required. And please let us think, lean, and act smart. Let us kill extravagance. From the policy issue that we talk about, I recommend that federal government, all tiers of government indeed, should have a unit where all policies are looked into with the view to synergizing them, integrating them, so that by so doing we reduce our consumption of resource and then put less ecological footprint on the environment. And I advocate that United Nations should really recalibrate its climate mitigation action. Carbon isn't the enemy, misuse is. We should push for 100% carbon utilization. And like I said before, the talk should be about decarbonization, not decarbonization. And because of my initial reluctance to be in the academia, even though I know this, it is my natural home, I hereby recommend to government that the academia should be given its rightful position in the scheme of things in Nigeria, and that the academia should be taken as the knowledge arm of the government, the fourth arm of government, and it should be placed at least at par with the judiciary, in all respect. And to bring this home, there is a need in UNILAG for us to integrate our utility consumption and wean it away from public supply, our water and our power. And we also need to shift our waste disposal from merely treating them to meet environmental regulation to resource recovery. This is the sustainable pathway befitting our status as the university of our choice and the nation's pride. And in line with the current drive for a future-ready university, Madam Vice Chancellor, I recommend that there should be a center of excellence on biomimicry, where scientists and engineers are put together to come up with models to copy from nature. This is the global trend, and the University of Lagos should lead the way in Africa. Acknowledgement. I thank Allah for all His blessings on me, my Creator, my Sustainer, my Guide. Indeed, which of His blessings can I deny? He is the first, the last, the manifest, and the hidden. Alhamdulillahi Rabbil Alameen. My parents. This is my dad, Elijah Dademo Usman, seated over there. This is my mom, Madam Aisha Usman. This is my stepmother, Hajja Salama Usman, who raised me. This is my father's bosom friend. He's late now, Elijah Isu Adankava. He was the one that enrolled me in primary school. My uncle, who is unfortunately late, and this is the wife. My uncle sponsored my university education up to the early stage of my PhD. Indeed, he would have loved to be here. He looked forward to today, but it's with Allah. My uncle's wife, Dr. AWWALU Usman, she welcomed all of us into their home, and she was the very first lab coat I used belonged to her. And you know, each time she's looking for me and she knocked on my door, she missed me reading. She will say, "Oh, Mohammed, you are an ideal student, too. Madam, your ideal student is today a professor. I rejoice with you." This is my mentor, my late supervisor, Professor Olu Oboja. Benefactor, I miss him so much. I thank the university management, beginning from the Vice Chancellor, Professor Folashade Ogunshola, and other members of management for approving today for me to deliver this inaugural lecture, and for all that they are doing for this university. These are my mentors and departmental colleagues. I thank you all. Professor Ogunye is here. Professor Ogunye is the father of the department, and he contributed in no small measure to all of the contributions that I showcased today without even knowing. I thank my dean, Professor Samson Adeocho. I thank all the other previous deans and all the colleagues in the faculty as listed. My student. Now, if I'm asked my greatest achievement in my near 3 decades here in this university, it is my student. I am glad that I have been able to make significant impact in all my students, and they acknowledge this. Thank you all. I thank the members of my organizing committee for this inaugural lecture, led by Professor Oshoba, and all the other members are listed there. I thank the planning committee. The planning committee is mainly made up of my past students, each state represented. I thank all my teachers from primary school up to university. I thank my classmates, AMCO boys of the 85. They are here. Thank you all very much. ABU engineers of 1990, thank you very much. I thank the board and management and staff of all the units that have worked in this university as listed here. I thank the professional body, Nigerian Society of Chemical Engineers, Indian Muslim Community, and the Birakan Development Foundation. These are the people I call my tribe of friends. I thank you all for all the support over the years, and for being there for me always. To my family, I say thank you for all the sacrifices, all the support that I've enjoyed from you. Thank you so much. I thank my in-laws. I thank my in-laws for their prayers, acceptance, and goodwill. I appreciate all of you. Now, God has blessed me with 4 wonderful children. This is the very first and the only daughter, Umeima. She's in the law school. This is Tolha. Tolha is a 400 level student of computer science. This is Murtada. Murtada just finished his SSC, one of those that scored above 300 in the last jam. And this is the baby of the house, Swali. Thank you all. I am proud of all of you. My late wife. I married this beauty personified in 2000, and we enjoyed our marriage for 23 years. She was a perfect wife, an angel, not a single moment of regret. I had looked forward to today to publicly celebrate her, but Allah knows best. He's now back with Allah. May Allah continue to show mercy on her soul. And when I finally decided to move on with my life, I reached out to a former banker, a coach, a public speaker, and human development expert, Dr. Aisha Daviruku, and she's now my wife. Thank you for your love, your care, and support. Thanks for being my special coach and cheerleader. Madam Vice Chancellor, you have just listened to the perspective of a process systems engineer on sustainability. This is the end of my inaugural lecture. Thank you. Thank you. Oh, thank you, thank you, thank you.
Please be seated. Thank you. We thank all of you for coming. You are all distinguished guests, and we appreciate you all. But we still have to recognize some of our distinguished guests who are here with us today. I will start by recognizing some former principal officers of this great university. Professor Oluwatoyin Ogundipe, the 12th Vice Chancellor, is here with us. Our father, Emeritus Professor Olaide Abbas, Professor Duro Oni, former Deputy Vice Chancellor, Management Services, Professor Oluwole Familoni, former Vice Chancellor, Academics and Research, Deputy Vice Chancellor, Academics and Research. We also have one of our distinguished mentors in the university, and also a mentor to the inaugural lecturer of today, Professor Francis Ogunye, with us here today. You are welcome, sir. Representing the governor of Kogi State, Alhaji Ahmed Usman Ododo, FCA, is the Secretary to the Government of Kogi State, Dr. Folashade Arike Ayoade. We also have Honorable Michael Onimisi Ajibade, Special Advisor on Climate Change, Kogi State Government. We have Engineer Richard Isaac, the Vice Chairman, Aviation and Aerospace, Lagos State Chapter. We have Chief Dr. Olatunde Abimbola and the entire members of the Onisheri of Isheri Olofi, the entire members of the Nigerian Society of Chemical Engineers, the entire family members of USMAN, Enesi, and Adaviriku families. We acknowledge the parents, Alhaji Usman, Madam Aisatu Usman, Hajia Salamatu Usman. The children of the inaugural lecturer, Umeyama, I hope I said it well, Salda, Mutada, Swaliha, you are all welcome. And to the spouse, Dr. Aisha Advariku, you are welcome. The Deputy Vice Chancellor, Development Services, Professor Folusho Leshi, the Registrar, Mrs. Abosade Wycliffe, the Bossa, Mrs. Olufunmilola Adekunle, the University Librarian, Professor Olatokunbo Okiki, the Provost College of Medicine, Professor Ademola Oremosu, the Dean, Faculty of Engineering, Professor Samson Adioshun, distinguished ladies and gentlemen, gentlemen of the press, Professor Mohammed Usman has delivered an enlightening inaugural lecture where we listened attentively as he was the judge, listening for fair hearing, and also the judge who gave the verdict. The lecture is titled, "Is Carbon Truly as Guilty as Charged?" And he gave us the verdict, and the verdict is that we should recarbonize instead of decarbonizing. Professor Usman's lecture brought before us a compelling argument, one that challenges convention and invites a conversation about the future of sustainability and steered a rethinking. With the precision of a chemical systems engineer and the clarity of a scholar deeply immersed in the field, Professor Usman re-examined carbon's place in climate change. Rather than joining the chorus that vilifies carbon, he made a strong case for context by placing the spotlight on the inefficient human systems and indulgent practices that waste resources and damage the environment. Drawing from his years of meticulous research, Professor USMAN shared insights from 5 major studies, each one a testimony to what is possible when engineering meets foresight. From retrofitting refineries and integrating food energy policies to valorizing waste and innovating greener industrial processes, his lecture showed that sustainability is not an illusion. It is achievable, it is measurable, and with the right tools, it is scalable. Perhaps even more important than the data and models was the reminder embedded throughout the lecture that nature wastes nothing, and neither should we. In advocating for a shift from net zero to net wisdom, Professor USMAN called on all sectors, policy, industry, and academia to rethink our approach. Sustainability, he urged, must move beyond buzzwords into systems, behavior, and design thinking. Professor USMAN's lecture is a call to strategic stewardship with an enduring value challenging us all to be more responsible in building a world where engineering aligns with ethics, where waste is minimized, and where sustainability is no longer an abstract goal, but an intentional practice embedded in policy, industry, and education. Professor MOHAMMED AWWALU USMAN, congratulations on giving a very interesting and excellent inaugural lecture with immense contribution to improving our society and the world at large. Congratulations to you and your faculty. I thank you all for coming, and I wish you safe journey to your various destinations. I hereby declare the inaugural lecture closed.
To find out more, join the upcoming 19th inaugural lecture at JF Ajayi Hall, University of Lagos, live on the 6th of August